Hello. Hi everyone, this is Hemant. I will be conducting today's session. So I see that a lot of people have been joined. So just give me a couple of minutes and we will start with the session. Yeah. First off, just let me know if I'm audible to you or not.
Yes, sir.
Okay, cool. Yeah. So let me just see if my screen. Yeah. Is my screen visible to you all?
Yes, sir.
So before we start with the session, let me just tell you that towards the end of the session, I'll be floating a feedback form link. So towards that, you can just fill up the feedback form link and yeah, you can actually avail the certificate for this particular bootcamp. And in today's session, we'll be talking about electric vehicle and its cooling systems, basically what different cooling systems are there and how efficient is which one and which is the most optimum cooling system that is currently being used, and why it is so, and all these things we'll talk in detail. Okay. So without any ado, let's start with the session. In the overall, in this particular session, we will talk about why, first of all, do EVs need cooling, electric vehicles need cooling. Moving on to different cooling systems, then exploring one by one what is phase change cooling system, what is air cooling system, fin cooling system, liquid cooling system. So all of these things we will talk about in brief. Yeah. Now, like I just want to know from you, why do you guys think electric vehicles need cooling? Anyone can unmute themselves and let me know.
Sir, cooling of battery and motor.
Yeah, I know what the purpose is, but I just want to know, like, why do they need? So what is the reason? Why do batteries need cooling?
Thermal runaway.
Okay, that's one reason. Any other?
The efficiency of the whole system.
Can you elaborate on that if you can?
Like it directly affects on the range and all that stuff.
Yeah, yeah. So these are the couple of things, but the basic principle is due to the electric vehicle components generate heat, right? So there are three major components in electric vehicle systems, which are the battery pack, the powertrain, the drivetrain, and the third one is the actual electronics, which are basically used to govern the infotainment systems and other control panels. So these are the three major systems that generate heat, and due to the battery pack's constructions, when a battery is excited, it generates heat. When you're actually charging it, when you're inserting energy into the battery pack cell, due to the excitement of the molecules, it kind of generates heat. So that is why the biggest reason we need to cool down the battery. Same thing goes with different electronic panels that due to the molecules excitement, due to the electricity passing through those electronics, they kind of generate it, they kind of heats up. And for the drivetrain, there are moving parts, there are different systems, due to which frictions and everything, the rest of the system generates heat. So this heating, first of all, impacts charging discharging efficiency. So if you're when you're discharging a battery, because it's a constant cycle with the batteries, you need to have a longer sustainability of a particular battery. So for that matter, you need to have an optimum temperature range within which the battery is contained, and basically it is operating, so that the actual efficiency of transferring of energy or storage of electricity is maintained. Now let's see what are the different problems that are there in EVs due to lack of better cooling system. So you might have heard about this incident that is currently happening in a lot of places with companies like Ola, Altair, that their vehicles that are basically due to overheating, they caught on fire, right? So biggest reason, or what could be the reason behind it, is simple. Like their batteries were overheated, or their components were overheated, and due to which it couldn't handle the load and it just catch fire spontaneously. So this would be the prime reason which is a most concerned reason with the safety of the electric vehicles, with the safety of overall operation, that we need to take care of it, we need to avoid. And due to which, like, we have different cooling systems in which we have a phase change cooling, we have air cooling system, we have fin cooling system, liquid cooling system. So let's see one by one what each of these systems mean. In phase change cooling system, basically, what do you mean by phase change? That is if a material absorbs heat energy, and it absorbs the heat energy by changing its state from a solid to liquid, or even liquid to gas, right? So usually we kind of in the typical battery packs where phase change cooling is implemented, there are liquid propellants or liquid coolants which are used to actually transfer the heat and actually occur the phase change. So here is one of these, this is a system which is basically used for using vapor propane. So it has a pressure regulator which has pressurized propane in its liquid form is stored, is basically being passed to this space, and that liquid propane is at a cooler stage. So it basically absorbs the heat that is generated by the battery packs, and then it is converted, it basically changes phase. And then it is again collected towards the end of this basically to condensate it, and again to regulate its pressure. So this is the general general way of working in phase change cooling systems. So the biggest challenge with phase change cooling systems is that when you are trying to change the phase, it can change the phase, but basically if you are using it directly, if you don't have any subsystem like a condenser, then it becomes difficult for it to sustain. So for the first pass, the propane or whatever liquid you are using, it is going to absorb the energy, and as it absorbs the heat, by changing the phase, there is very little change in temperature, and afterwards the temperature keeps on increasing of the rest of the vapor that is being generated. And if there is no condenser, then in that case it becomes like a constant temperature in that scenario, and due to which the overall system becomes heated. So basically there is a requirement of another subsystem in this particular cooling system, which basically adds on weight to the whole assembly, and essentially is not well sought after, basically. So this is the general idea about the phase change cooling system. Now, if we talk about second stage, which is air cooling system. In this air cooling system, we have suction fan. So it sucks in the air, then it kind of blows the air over the battery pack, over the units, and essentially it is it is cooled with the blowing air. And when the air temperature rises, basically have different channels through which it basically goes. Like if you can see over here, just a minute, I'll use a pen. So the air intakes from here, this suction fan sucks the air and kind of pushes it through these channels. Then from this channel, it basically goes into battery units in this manner. And it basically envelopes the battery pack from the bottom side as well as from the top side. So as you can see over here, the color indications, slowly the air gains temperature, and with this outlet over here, you have the hot air, which you basically exhaust from this air outlet. So this is also another type of a cooling system, which is basically used for cooling of different like batteries. But if we need to extend this cooling system to, let's suppose, all the different components like the powertrain, the electronics components, there will be essentially issues. So, like my question is, like, what kind of issues we will be facing if we extend this overall system to the components? Can anybody tell me? Okay. Okay. So the idea is basically, in order for you to, if I will just give you a better explanation in this empty sheet itself, empty tab itself. So let's suppose this is the electronic component that I have. This is my drivetrain components that are there, and this whole is the whole battery pack. Okay. Now, over here, what happens is, due to the and here is my the suction fan, okay, which basically blowing out the air. If I extend the air from this component, if I use a single loop system, basically, what do you mean by single loop system? Is you have one single loop which is basically passing through all the different components and coming back to the radiator. So due to this, what happens is, at a certain point, the air basically is having high enough temperature, due to which it basically is unable to cool off the rest of the components, and due to which you actually kind of need separate systems for cooling of the different components. So this is the kind of a drawback for the air-cooled system, and due to which basically we have this. Basically, it is also not being used in that better context as well. So this is basically, it is ideal for a smaller component, or with a singular component level. It is ideal for. But again, there is a complication of installation of suction fan and how the air is going to propagate throughout the circulation system, and due to which this is basically is not well sought after. Coming to the next kind of a cooling system, it's a fin cooling system. So fin cooling system basically it's also limited to component level system. It also uses, it's kind of an extension of the air cooling system itself. So if this is your battery pack, then you will basically install fins all across the battery pack and basically blow the air over it. Okay. So what it does is, from the battery pack, you can install basically this heat is being transferred to these fins, and these fins are open air, and they kind of absorb the heat. They kind of convex the heat to the surrounding. Now this additional blowing system is also needed in this particular case. for which it becomes very installation wise, it becomes heavy. It becomes in certain cases impractical, because if you consider battery pack size itself and its weight itself, it is within the range of 100 to 200 kgs for bigger vehicles, for trucks and for cars and stuff. So in those scenarios, what happens is you cannot add on more weight to it by just installing fins and by installing all these kinds of different systems so that it will cool the systems off. Because basically it's a trade-off between installing having a cooling system and achieving the optimum efficiency with the weight of how much amount of energy the overall equipment system will consume in order to move the vehicle. Because essentially you are using the same energy that is being stored in the battery packs to drive the vehicle. If the weight is more, essentially it will consume more electricity, consume more power, right? So these are the different parameters that are basically being taken into consideration while you are actually operating with these kinds of different subsystems. So then what is the better way to go, right? What is the current way to go? Current way to go is with liquid cooling systems. So with liquid cooling systems, it is a slightly bit of a complex structure, if you can see. Basically, you have a liquid cooling system in which you can actually pass on the liquid from one channel to another channel, and essentially it uses the same concept. Like if you have different components like this, it will basically use same concept by passing through the liquid over the battery pack, then passing through the liquid over to the drivetrain, to the electronics, and then bringing it back to the radiator to cool it off, right? But the advantage with this kind of system is big due to the capacity of converting heat with the liquid cooling systems, right? As compared to air cooling systems, air also has a disadvantage of expansion. In liquid's case, it is not there to a certain extent. So due to which, with your liquid cooling system, it's much better to actually have this system propagated throughout this. Basically, have this liquid provided throughout these cooling systems. Now, coming to the actual implementation of how this is basically being used is, let's just take this example. Okay. So you have a battery pack, you have a drive unit, you have an outhouse, you have a radiator. This is your radiator, or basically a system through which your liquid is going to get pumped out. So this is a single loop system. Okay. This is a single loop system in which you basically try to pass the liquid using this pump. You are pumping this liquid to pass it through the drive unit, then again pump it to the outhouse, because essentially it is located at the top of the drive unit, and then again passing it through the battery pack and then retaining it. But the problem with this kind of system is essentially we have again a single loop system with which we are unable to utilize the maximum efficiency of the liquids, because essentially your liquid is going to get heated up towards the end of this, and it won't be able to convey the heat with the optimum range that we want it to be. So usually with the battery packs and with the electric vehicle systems, the overall system temperature should be within 15 degrees to 35 degrees. And if it basically, you need to maintain this range, you need to maintain the overall temperature within this range of each individual components. Now, to resolve this kind of a problem, what exactly is being done is installation of double loop or dual loop system. So here what happens is basically from your radiator, if your liquid is your cold liquid is coming from this pipe, and it is basically separated with two loops. So the first loop is basically it's going to get pumped up to the battery, and again battery is separately cooled. with the same liquid, like at the intersection itself from here, it is again propagated through the rest of the systems from the drive unit and from the outhouse, and again it is recircled back to this output pipe of the of the overall system. So basically over here, then it is cooled off using the radiator. So this is the actual drive system which most of the companies are using with a dual loop system, which is working currently. But the biggest issue with this is it's very complex. You need to build a very complex system. Again, it uses glycol water mixture as its liquid coolant. So glycol is very volatile. In case of basically, if this liquid coolant is very hazardous, so there should be absolutely no leakage while you are propagating this liquid throughout the whole system. So that is the biggest challenge that many industries are facing. So or design a very complex system, to design very proper channel ways, because again, with each and every battery pack, there are different cells within each battery pack, right? So you have to have individual kind of a pathway or passage through each battery pack, and also there is this challenge of keeping the whole temperature of the whole battery pack as common temperature. The biggest reason or issue comes here with each cell is, well, while your battery pack is basically generating heat, you need to make sure that the temperature of each cell is more or less the same. Because if there is this difference of temperature with each battery pack, then the charging to discharging ratio, the basically discharging efficiency of each and every cell is getting impacted, due to which when you are discharging a battery, when you are discharging a particular cell, suppose if this particular cell is at 35 degrees, but if this particular fellow is at, let's say, 40 degrees, then this is temperature imbalance. So the overall unit is getting affected, and whatever liquid is passing through these systems, simultaneously it is also getting impacted. The overall cooling system is getting impacted, and this can lead to improper cooling. This can lead to remnant heat inside the overall battery pack, which again deteriorates the overall performance. So these are the bigger challenges that are basically being taken care of in current day and age in order to improve this overall system. So yeah, that's the general overview about this system. So if anybody has any questions, I think some of the people have put in some questions in the chat. I'll just, sir, why is liquid cooling best than air fans? The overall, like basically it is simple. If you are using air, the capacity of air in order to convey the heat is much lesser as compared to liquid, because your liquid has more thermal conductivity. And when you are passing the liquid also, for air also, you need to have a very guided pathway, as opposed to with liquids. You can just install channels, and essentially in case of liquids, if you pump it with the right amount, it will propagate through the whole system with much smoothness. As opposed to air, you need a very proper system in order to navigate that air throughout the whole system. Again, your air gains temperature. You need to recirculate, basically, that you cannot basically extend it to other systems. So even if you consider single loop systems, the installation of the installation of air fans and everything, it becomes very difficult. And also for single loop systems, as I already said, the biggest disadvantage is that only, that when you are extending the air through different components, it again has more disadvantages in terms of temperature rise. And basically, it can also backfire in terms of instead of cooling the component, it can also heat the component. For that matter, again, you need to install more powerful fans, and again, you're using the same battery pack to power the fans as well. So it kind of becomes a trade-off between either you have a more powerful cooling system, but it consumes a lot of energy and you need to constantly recharge the batteries. Basically, it reduces the range. And as opposed to if you are going to replace the system itself with liquid cooling system or with other cooling system, then it becomes again it's a trade-off between then it becomes much more optimum in terms of operation, like where you will have a better temperature convection. Also, with the air, there is this bigger disadvantage that you need to have exposure to the surface area as opposed to if you are installing the liquid channels. So you can basically ensure that wherever the liquid is going, you can actually make it properly propagate through the pumping system, because liquid is incompressible. So air is compressible, right? Air is free. So due to that, that is also a bigger factor where you are pumping a liquid as opposed to you are pumping air with the same amount of power. Then it basically won't be able to pump out, or basically the thrust or the overall propagation of the liquid as opposed to air is much more easier in terms of circulation. So, yeah.
Hemant, I have one of the most important today in Indian context for operating at a very high ambient temperatures, going up to 50, 55. This is one of the very important aspect to study some of the basics and support the industries. I have two questions. One is, what type of shielding of this battery? Is this metallic shieldings, battery packs, or any polymers or plastic things? That is one thing which people can think of working how to maintain the overall temperature 15 to 35 degrees. Second thing is definitely this new technology like phase change cooling system to be considered, considering the weight of the battery system by liquid cooling system.
Yeah. So to answer you for your first question, what kind of material or what kind of shielding is there, right? So usually people are actually adapting to the polymers, as you said, to plastics, as you said, which are highly thermal conductive, and through which you will have better convective rates, and essentially the liquid cooling systems are also there. So yeah, there is a bunch of materials, but I'm not sure about the names at this stage. But yeah, I can actually probably look for them, and I can give you a better description of those in a later stage. But yeah, that is the first solution. But in India also, this is a bigger issue. Like in terms of temperature rising, there is a lot of hot places that are there in many regions. So the better way to go at it is again installing a better cooling systems, which are at this day and age are liquid cooling systems. But again, with the liquid cooling system, there is this complex scenario of installation. Like you need to have proper passageways. You need to ensure that wherever the liquid is going from, what sort of temperature it's going to get built up, and again to recirculate it back, and what sort of heat capacity it has, and then accordingly drain that heat from the liquid, recirculate it throughout the system. Then there will be a need of condenser. There will be need of all different components in order for you to actually cool it off. So usually people are using radiators only, so for the condenser and for cooling it off. But yeah, this is a bigger challenge in terms of phase change cooling system. So phase change cooling system is also the bigger challenge with it is again when you're changing a phase from of a material, it basically absorbs the heat in its latent form, and that heat is basically utilized to change the phase of the material without raising the temperature. But after you raise the temperature, you again need to switch back to the original phase. and then again recirculate it. So then this recirculation thing is going to be always going to be there. And if in case you don't need to have that recirculation stage, because essentially you're working with a lower temperatures, like let's say 15 to 35 degrees Celsius you are working at, and in those cases liquids won't be suitable, but coolants will be suitable, like coolants like ammonia based coolants, or also essentially propane. So these are the in normal temperatures they are in their gaseous state, but you again need to have have them under very compressed state. So you need to maintain the pressure so that there will be pressure regulators needed. So there are all of these complex things that are currently being researched on. And yes, for the future of the cooling systems, phase changes, of course, has better potential. But with the ease of operation and installation, liquid cooling systems are much sought after. Or basically, from implementation point of view, from research point of view, they won't need that much amount of time. Sure, they are complex, but for phase change material, you actually need to derive some on a material level, on a material properties level, what sort of different materials are going to be there in order to use usability, and all these things are going to be there. But yeah, another aspect of this phase change is basically using heat pipes. So again, heat pipes are used in smaller electronics, like they are very micro devices. Basically, it uses a wick, which is a wet wick, and it has a coolant absorbed in that. It's a sponge kind of a thing, which is installed in a cell, in which the overall cell basically transfers the heat to the wet wick, and it basically like evaporates the coolant inside that wick. Again, due to the evaporation, it goes to one side, and again, so it's a very complex thing. If I show you in a very simple manner, what happens over there is so this is a general structure of a heat pipe. It has a wick. This is the wick that I'm talking about, a sponge-like structure, and it is partially wet. So let's suppose it is wet from this side. If you are heating it from this side, then it kind of evaporates, and it moves towards the colder region. So this is your colder region, this is your hotter region, and it kind of moves from hot to cold. Here it condensates and settles down again. When the condensate droplets goes over here, this wick absorbs it, and again it transfers it from this point to this point. So this is how it is usually.
What about the basic battery materials inside, like electrolysis process, including that? Is there any new substances are being worked out to reduce the heat release during charging and discharging? One is cooling, another thing is heat release by the batteries while charging and cooling. Any good materials is being thought of by the research people?
I actually haven't looked that much in the material science of these battery packs and what kind of materials are used. But yeah, essentially, the point is there are materials that are being sought after. More probably, there is there are different materials still there. I'm not aware of them at this stage. Yeah, I can probably look for them, and I can give you a better answer.
Okay, thank you, Mr. Hemant. Continue.
So there are a couple of questions in the chat as well. So Abdullah asks, technically, what is the difference between liquid and phase change cooling system? So again, this is the basic difference. If we talk about with phase change, you might have so with phase change cooling system, you are changing the phase of a particular material from liquid to gas. In liquid cooling systems, it's not there. So basically, you will have the liquid will again gain temperature throughout this process. Again, the radiator will cool it off. It will not go into condensate form. Basically, the coolants that are there in liquid cooling system, most probably current systems are using as a mixture of water and glycol. So throughout the process, the liquid stays liquid. As opposed to in phase change, the absorption is different. Over here, throughout the whole system, it's very simple. In liquid system, what happens is the temperature will keep on increasing. Then coming here, it will reduce down. Again, it will recirculate. So this way it will work. In phase change, what happens is over here, whatever liquid propellant or liquid coolant you will have in this vacuum space, it will change its phase by remaining at the same temperature. Let's suppose if the phase change temperature of any X liquid or X coolant is 20 degrees Celsius. Okay, so till the liquid changes its phase from liquid to vapor, the whole temperature remains 20 degrees Celsius.
Is
So-
it wax are also being used? Wax can get melted at higher temperature, then heat can be transferred through certain system. Is the phase change systems also include wax as a coolant?
Wax, not to my knowledge, because wax has very different properties. What the liquid, the coolant that we're talking of at this stage is very pressurized. So essentially, you will work with this. This coolant will have temperatures in negative range, like minus, let's say, minus 30, minus 40 degrees Celsius of temperature. It will have. It will be very compressed, and then it will be. So here, as you can see, this is a pressure regulator for collection. This is a liquid propane tank. So in this liquid propane tank, it is highly pressurized liquid propane. So due to which you are working at negative temperatures. The initial temperature of these propane is negative, is in negative ranges. Then when it rises the temperature, it will be in the optimum range of the 15 to 35 degrees Celsius that we need the batteries to be worked upon. Again, what I was talking about with the phase change, the issue is once you increase the temperature, right, it is difficult for you to go back to the negative temperature. So there you need a condenser. There you would need a compressor. So for that matter, we will have an additional components installed, and the additional components again increase the weight of the overall system, making it difficult to trade off between the weight and the actual operation. So yeah. Coming to the next question, how is the size or capacity of a cooling system decided? Okay, that's an interesting one. It depends on the amount of. So yeah, it depends on multiple factors. The first factor is amount of heat being generated using each individual component. Then, how much amount of system, or how much amount of liquid or anything that is being needed in order to keep the temperature within the range of 15 to 35 degrees Celsius. Then, once you figure that out, how is the bigger question? Like, how are you going to circulate the liquid throughout the whole system? Whether do you need two separate systems for two different components? Whether you need whether a single system would work throughout this model. So that way it is decided. Then size essentially depends on the size of the rest of the components, like what size of the battery pack you have. Then that itself will decide how much amount of energy it will release, and that is essentially going to impact on in order to how to dissipate the energy. You would need what kind of a system, and again, how much amount of liquid is needed. So at a particular pass. So I'm talking this in the context of a particular pass of, let's say, you will have a circulation system. You won't have like a single this system over here. So basically, with single pass, if you are releasing X amount of heat, or you are convecting X amount of heat from the battery pack, that you need to maintain. And then when coming back to the original source, you again need to cool it off, then again recirculate, and again it will still reduce, it will still extract X amount of heat only. So this X amount of heat you need to then calculate. Then that becomes that will give you a proper conclusive answer on what sort of coolant you are going to use for dissipating that, because it depends on the thermal properties of the coolant as well. It depends on the circulation, so the different circulation systems are being tested for this kind of scenarios. So yeah, that is there. Yeah, can you list some phase change materials for cooling? Probably I'll list those afterwards, like once I do a bit of research on materials. Because today's topic was to talk about most optimum cooling system that is currently being used. Even Tesla is currently using liquid-based cooling systems only. Also, that reminds me one thing. Similar to liquid cooling system, there is battery heating systems are also being needed. So not in our country. In our country, there is temperatures already within the range of, like, let's say the average temperature ranges from 24 to let's say 40, 45. On most days, on an average scale, it ranges between these. Scale. But in European countries, in America and everywhere else, there is the average temperature throughout the season or throughout the year is lesser. So in Canada also, the temperature is in freezing cold temperatures are there. So in those cases, you need to give the batteries an initial start. So for that matter, you actually need a heating system as well. So that there is this redundant energy in motors. So when you're operating with electrical motors, so they have this they use this phenomena where the motors essentially are generating heat, and that heat then is propagated through this cooling system. Basically, the coolant that you're going to operate on is going to circulate the heat from the components from the motor itself to the rest of the components to heat them up and to get them going. So that's how basically heating the battery. That's how, because it's initially you need to have a battery at a certain temperature. If it's too cold, again it won't work with the fullest efficiency. So you need to have the battery at a certain temperature. That's what I said. Like 15 to 40 degrees Celsius, you need to maintain temperature. So the current with the difference of these temperatures in other countries, what happens is the temperature is already well below zero. In some cases, it is also minus 15, minus 20 degrees Celsius. So to transfer from that minus 15, minus 20 degrees Celsius to 15 degrees Celsius, you need to establish a heating system as well. So whatever systems we are talking about in terms of cooling, it's basically reversed, and then it is recirculated. The heat is basically utilized to heat up the batteries, to prepare them, and then you're actually going to start the EV, and then you basically will be able to operate it. Is there any new configurations that make use of both phase change materials as well as liquid cooling to give better cooling? Yeah. So it is very impractical if we think about this. Why? Because liquid cooling is essentially a very complex system. On the top of that, if you are simultaneously using a set of batteries, like if you are simultaneously using phase change materials, then it kind of contradicts the whole like operation. Again, it adds on weight, it adds on the different parameters are getting affected by at a different level. So if you're using it simultaneously, then probably you need to figure out like a certain section will be cooled using liquid cooling system, a certain section will be cooled using phase change materials. Again, there is this the dynamic between those two should be very well calibrated. So at this stage, there are not many people going for that option because it is a much expensive option as opposed to the current scenario. But yeah, that could come in future if you have better materials in that context. What happens when we use both air and liquid cooling systems in single vehicle? Nothing much. You can have a better cooling system, but essentially with a trade-off of discharging your battery too quickly, because both of them are using same operation. I think I had mentioned this previously. Biswa says phase change cooling system constitute the latent heat and also the specific heat, as latent heat has high value of enthalpy absorbing capacity. That's why phase change is a better cooling system. Yes, this is a very great point. Phase change is indeed a better cooling system, but current scenario is very difficult in order for us to implement the phase change cooling systems, because it has this issue of once you change the phase, then what? You need to change it back. So with liquid coolants, it is much more easier, but again, it requires support systems to sustain it. So in current scenario, it becomes expensive option as opposed to liquid cooling systems. So that's why it is currently being explored, and currently we are using liquid cooling systems. Yeah, this also says wax as a coolant cannot be used due to its low flowability and low latent heat value, and wax has high viscosity. That's why it's not flowable. That's why I think wax cannot be used. Exactly. The biggest challenge with wax is the melting temperature itself. You need to have scorching temperature in order to melt the wax. And again, it is to cool it off. It will again require a different subsystem. Not phase change is very challenging in that case. Yeah. Yeah. So that's all about the questions. I'll just put in the feedback form link in the chat. Just a minute. Until then, if anybody has any more questions, they can share. So by filling out this feedback form link, you'll be eligible for a one-on-one counseling session from our experts. They will be understanding what needs you have. They will be understanding what sort of interests you have, and accordingly recommend you better career options. And accordingly, you can actually get a free course from us in the domain of electric vehicles, in domain of different domains. We have courses in like data science and free courses basically. So you can avail those free courses through this by filling up this feedback form link. So yeah, you guys also will be able to better understand where your career is headed and what sort of opportunities are there in future. So yeah, do fill out this feedback form, and I'll be here for a couple of minutes. If anybody has any more questions, they can share. Arun, is there any internships from your side and for the jobs? Yeah, we do have a support, but it again, when you're consulting with the expert, you will be getting to know more about those things. Thank you, Biswa. Thank you for your inputs. For people who don't have the feedback form link, I'll again share this. Thank you, Sriram.
I think, Mr. Hemant, probably we need a one more session on this because this is one of the very, very important issue, particularly for a Indian application where ambient temperatures are going up to 50 means I really don't know. All these accidents are because of the heat or because of the leakages of some battery electro materials or short circuiting of electronic circuits. We don't have much information, at least from the cooling system. People should address the topics like what type of shielding material are more useful for Indian context by looking at the battery manufacturers, also like ARII, Pune, where and some of the good colleges in Pune who are working on electric vehicles. I request please put it in your chart. I don't know.
Yeah.
Put this into that and let us get connected and you should also give some exercise for participants to do some homework, what type of work they can do, what
Yes.
type of material they have to concentrate, where to contact, whom to contact. All
Exactly.
these things are really essential from ETC to put in your whatever that chat box or whatever. Let us also work together in working together, encourage the youngsters to take up a innovative solution for electric vehicles.
Exactly. That's the point of this whole thing. We need to share awareness. We need to spread awareness where we can actually make people think and they can actually develop solutions. So that is the best way to go. If a person wants to do something about it, they need to be able to think. They need to have resources. They need to be able to do the research. So yeah. One thing I can do is I can write this thing down. I'll probably do a better research on it, like what sort of this specific to this particular challenge of ambient temperature being a big issue in terms of operation and in terms of creating a better cooling system for it. So what sort of research is currently being made and how things are operating towards. So whatever materials we can find, we can share that context, and people can also learn a couple of more things through this. So yeah, it's always appreciated. Yeah, and apart from the hands-on exercises and all these things, it's already in plan. So we'll figure out like what sort of things we can do in terms of spreading actual growth. So yeah, they're also there. So coming few sessions, you might see some of these implementations of hands-on exercises for students, so that they can actually do something and actually understand how it works. So, yeah. Okay, everyone. That's it for me. Those great. Everybody had very interesting questions. Thank you very much for attending this session. And I really hope that you guys had filled the feedback form. It will be better for you guys to actually sign up for the one-on-one session, and where you can actually understand where you want to go and what are the opportunities and how things are going to go. So that way you will also be able to learn a couple better things about electric vehicles and how it operates, and much more guided way you will be able to learn all these things. So yeah, thank you very much, everybody who has commented. Thank you, Rahul. Thank you, Sudhanshu. Thank you, Jen. Sir, thank you very much for your insightful opinions. Yeah, I'll take a note of your contact details and let's connect at a better place. Thank you, everybody. I'll be signing off. When can we get our certificates? Oh, so once this bootcamp is processed, usually it takes time about a week or so. In case of you don't understand, you can actually in case you don't receive a certificate, just check your spam folders. You just check all the folders that you have. Basically, we share the certificates using Gmail. So make sure to sign up with the correct Gmail ID. Also, it's also important. So yeah, that way we can connect. Yeah. So thank you very much. Try to conduct these events on offline mode. Yeah. we are trying to have something going. So yeah, probably in future we might be able to, which will give us a better scale. So yeah, that is also taken into consideration, Vedant. Thank you very much for that. Yes, you're right, Vedant. Offline also tends to give a better context, more deeper understanding. So yeah, currently we are trying to figure out like how things will go, but yeah. Okay. Again, thank you very much. Have a nice day, great evening. Whatever you have learned through the seminars, through sessions, what we do is the point of these sessions is to to share knowledge. So if you guys find anybody who is curious about these kind of things, whatever you know, you need to share. You need to get things going. You need to have brainstorm on different ideas. That's how you learn. That's how you explore. That's how your curiosity gets piqued. So that's one advice from my end. Yes, Nandini, you can unmute yourself if you want to ask something.
Thank you, all participants. Get connected, spread this message. All of us should get into these challenges, what we are really facing for introduction of electric vehicles at an early. And I wish to greet all the participants. Happy World Environment Day. Tomorrow is World Environment Day. Try to celebrate by your awareness program, sharing session, planting the trees, conserving natural resources and all. Please get connected for any of such informations. I was in Bosch for R&D 35 years. Now I retired 10 years back, but still I get connected to the society at large, engineering colleges in Karnataka.
Wow.
Thank you. Please celebrate World Environment Day tomorrow by planting at least one or two saplings in your home itself. Buy some 30-40 rupees plants, keep it. It will be a good contribution to the global warming and climate change. Thank you all. I have shared my contact details. Anybody wish to talk, you can also talk to me sometimes. Thank you. Thank you. All the best, Hemant. Thank you very much.
Thank you, Jana. Thank you for those lovely words. It was great. So yeah, let's conclude the session. Have a nice evening, everyone. Keep learning, keep exploring. This is Hemant. I'm signing off. Bye bye.